Most people think once security scanning tools are added to CI/CD pipelines, the systems become secure. That is completely false. Today, I'll show you a production style DevSecOps problem where the pipeline scans Docker image, vulnerabilities are detected, but deployment still happens. If you want to work on real production systems, this is the kind of thing you need to understand. Not just tools, but how security failures actually happen. If you are new to my channel, subscribe and comment DevSecOps so that I know you are following along with me. All right. Now I'm going to jump to Visual Studio Code. Here we have episode 1 folder followed by episode 2 vulnerable image. Here I'm going to write a new file application.py. This is very simple application code which I'm going to write. So here if you see, we are just creating a basic Flask application which is returning vulnerable container demo. That's it. I'm not explaining huge, I'm not taking complex applications here. The goal is very simple, to make sure you guys understand DevSecOps problems. Now, I'm going to create another file, requirements.txt, wherein we are going to write Flask dependency, which we are going to install, followed by we are going to create a Docker file. So I'm going to write a Docker file here, and in this Docker file we are going to write some code. Again, I have a full Docker Home Lab series on my channel. If you don't know anything about Docker, please go watch that and come back to this series so that it will be easy for you to understand. If you look at this Docker image and if you know Docker, then definitely you know the answer. This particular file is a problematic file. Why? Let me know in the comments what do you think, and also by seeing this file, write down what all are insecure in this particular file. So starting here from Python 3.8, okay, this is an old image, right? Python 3.8 is like a very old version. That image I'm trying to use here. That means outdated system packages, vulnerable libraries, unsupported dependencies, and many teams never update them. This is the reality. Even today, production environments try to run these kind of images due to so many different reasons. It's not like they cannot use latest versions, but due to some different dependency issues, they still use old images. Okay, now I'm going to build this image. First, let me check if I'm present in the right folder. Yes, I'm in the right folder. I can run docker build command here and we can build this particular image. So the image got built successfully. I do not see any kind of problems here. Followed by, we are going to run this real quick. For that, I'm going to say docker run port 5000 vulnerable demo colon version 1. Now, here's our first problem. So if you see, cannot import URL code from this particular name, blah blah blah. Okay, we came across one problem now. So how do we fix this? I know the fix because I am working on this. from some time already. So I'm going to add this particular dependency, and let me build the image once again. So Docker build vulnerable demo v1. The goal is to show you DevSecOps related stuff problem. Please forget about this particular dependency issue. This is common because I'm using the old version. Now I'm going to run this real quick. So if you see, now it is successful. I'm able to run the container. Let me jump back to the browser. Now I will say localhost port 5000, enter. If you see vulnerable container demo, this works perfectly fine. Our application is running, container works. From the functionality point of view, everything looks perfect. This is the same exact code which we have in our Flask application, vulnerable container demo. But security problems are invisible at this stage, right? Did you figure out or find out any kind of security issues so far? No. Now, we are going to install a tool. I would like to run wget command to download Trivy from official website. I'm going to give you all the steps in the readme file. Don't worry about this. Followed by, I'm going to run echo dbn command. Then finally, we are going to update our system. Followed by, we are going to install Trivy. Now we are going to install Trivy. So Trivy installation got successful. I will try to run Trivy -version. I can see Trivy successfully installed on our machine. Now the goal is to run this particular image using Trivy command. So I will say Trivy followed by image vulnerable demo version 1. We have this image built locally, so we are using Trivy tool here. Press enter. So if you see, it is trying to update the DB here, downloading vulnerability DB, followed by downloading artifacts. Then it is trying to scan now. If you see, licenses acquired from one or more metadata, and we see so many different issues here. For example, high CVE package index.py, followed by, if I scroll up, I can see medium level CVE. Okay. Then if I scroll up more, I can see one more medium level. High resource consumption leading to denial. Then I see another high CVE. Same related to workzook when parsing multipart. So yeah, if you see, it found total 20, 3 low, medium 10, high 10. Okay, these are related to Python package. So if you see, we can see so many different CVEs here. I'm not going to look into details. This is expected because I'm using an old image version, right? We are using old Python image version. That's the reason we are seeing high, medium, low, all these kind of CVEs, which are very, very important because vulnerabilities got detected once we use Trivy tool. So people think security is working, but not necessarily. Because see, once we figure out this, most of the people think, okay, we have a CI/CD pipeline in place that will take care of the security issues, right? This is very, very common, I'm telling you. Some people, do it by themselves. I mean, they try to fix it. Some people do not even try to check locally on their machines using Trivy command. They think, okay, we have CI/CD pipelines in place. Let it test. Okay, it's not their responsibility. Some developers think it's not my responsibility. We have a pipeline in place. It will take care of any kind of CVs where we come across. So what I'm going to do now, let's create a file dot github followed by, let me, on the root level, I would like to create this. So let me copy real quick. So I'm going to create a file here. No, sorry. I'm going to create a folder here first. Dot GitHub slash workflows. Followed by, in this folder, I'm going to create security.yaml file. Okay. So once we create this security.yaml file, I'm going to write some GitHub Actions CI/CD pipeline. This is again, I already explained in detail about this particular CI/CD series. I'm not going to explain once again in detail. So very high level, this is, let's say, a security scan. If you haven't watched my CI/CD series, then definitely you have to watch that to understand everything in detail. On push to the main branch, we are running on Ubuntu latest. We have a checkout step here. We are trying to build the image, and then we are trying to run the Trivy. That's it. Image reference, we are trying to give vulnerable demo version 1, table format, exit code, severity high. It will try to check for high severity issues. Also, I would like to update here. So this will run on in this particular directory because our files are in this particular folder. I don't want to run it on episode 1. So it will run on episode 2 vulnerable image. This is very important. If not, the pipeline will fail. I'm going to save this real quick. Followed by, we are going to add git commit -m add episode 2 vulnerable image. Then let's push this. So as soon as we push, we have the source code in our repository. Now let's jump back to the workflow details. And if you see, the pipeline is running right now. It did try to set up job, check out the source code, building the image, followed by, let's see what will happen next. Now look very carefully in this particular step. Run Trivy. We are using Aqua Security Trivy action, followed by, we have an image here, format table, exit code 0. Look very carefully at this particular line, exit code 0. Even if vulnerabilities are found, pipeline still succeeds. This is extremely common in enterprise environments. Security scan exists, but policy is weak. Having security tools in place does not mean you are secure. So if you look at our pipeline, the pipeline is green. It tried to check out the source code, followed by it tried to build the image, as you can see very clearly, Docker build vulnerable demo. Then we try to run Trivy. So let me scroll down. Here I can see so many CVs, so many different problems, and we have it in a table format, as you know, we wrote in our pipeline step. I'll try to keep scrolling here, and I can see so many CVs here. Then it try to run post steps as well. The pipeline is green, right? This is very dangerous in production environments. Security issues are visible, but deployment still happens. Now, let's imagine I'm going to add another step here. After Trivy, so what is the next step? So, I mean, in general, once the scan is successful, we are going to add a deployment step, right? I'm just trying to show you a brief demo here. We are not actually deploying. I mean, in reality, after the scanning is done, we are going to deploy to Kubernetes cluster, or maybe ECS or maybe Azure Container Apps. It can be a production VM. I mean, multiple places we can deploy this, right? I'm going to add this real quick, followed by git commit -m add deploy step git push. Now, if I jump back to my pipeline, so if you see add deploy step, the scan is running right now. Now look at the pipeline. Once again, it tried to run the application, it tried to build it, ran Trivy, and also deploy was successful, right? Most security failures are not because scanning is missing, this particular step, scanning, they happen because thresholds are weak. Teams ignore all these findings. Pipelines prioritize delivery speed. Temporary exceptions become permanent. Majority of the teams try to add exceptions saying marking it as temporary, but they become permanent. This actually happens in real production enterprise environments. Okay, I'm stressing it because I've seen this from my own experience. That's the reason I'm trying to teach it here as well. So how do we fix it properly? I'm going to jump back to the Visual Studio Code, and here instead of exit code 0, I will add it as 1. Very simple minor change. All right, followed by critical comma high. Okay, we are making it more stricter here. I'm going to save this file, and then let's try to add this real quick. Git add git commit -m update pipeline, followed by git push. Now let's jump back to the pipeline once again. Now let's look at the difference. As usual, it is trying to check out the source code, building the image, followed by it will try to run Trivy once again. The pipeline failed with an error. Looks like I made a simple mistake. Let me jump back to the Visual Studio Code. Yes, I have a space in my severity critical comma high. So let me add that real quick. Git commit -m remove space. Then I'm going to push this real quick. The pipeline started running once again. Now pipeline fails if dangerous vulnerabilities exist. So this is exactly what we changed. So if you see, we have so many vulnerabilities. So that's the reason the pipeline failed and it did not proceed to deploy step. Now security becomes enforceable, not just informational. So if you see, previously it was passing, we had a green pipeline, successful green pipeline. Now we have a failed pipeline. Wantedly, we added exit code 1 because we want to fail our pipelines if there are any vulnerabilities. This is how we add strict policies within the pipelines so that the pipelines will not go green, and also we are not going to deploy it to production. Now we are going to update this base image with Python 3.12, followed by we are going to update the dependencies as well. I'm going to remove all of this and I'm going to add Flask 3.0.0 here and follow the same process once again. We are going to build this image. Again, we are going to run this and push it to the pipeline. And also we try to scan it locally using Trivy. Always make sure you're updating your base images regularly because it is very, very important. Many vulnerabilities disappear simply by upgrading this base image. So once you update to the more latest version of the image, it would be little bit much clearer than the old 3.8 version. I mean, you can see issues with this particular image version as well. We have a different concept of, wherein you will not have any kind of vulnerabilities. For example, Docker hardened images. I don't want to go into details of that, but for this episode, I want to keep it simple so that you understand what I'm trying to explain and what kind of problems we see in real production environments. So, in episode 1, we saw insecure infrastructure. Today, we saw insecure containers. Next episode, we'll look at how Kubernetes RBAC mistakes can expose the entire cluster. This is why DevSecOps is not just adding scanners. Security only matters when policies are actually enforced. Otherwise, pipelines become security theater. Thank you for watching and see you in the next video.